Hey everybody, welcome to NASA's Jet Propulsion Laboratory here in Southern California. My name is Stephanie Smith. I'm part of the digital news and media team, the social media team here at JPL. And fewer than 48 hours from now, I can't believe it, our countdown to Mars is nearly done. Our Perseverance Mars rover is nearly to the red planet with landing this Thursday. We wanted to take a time out and bring you all behind the scenes on a very windy day here at JPL and give you a chance to meet some of the fantastic human beings behind this mission, take your questions live, and get them answered. So if you've got questions about science, about technology, particularly the Moxie instrument, Moxie technology demonstration, or engineering of landing on Mars, we're going to take you inside mission control. So without any further ado, just keep those questions coming. You can use the hashtag countdown to Mars. You can also put them right here in the comments. Here to tell us more about the science of this mission and its search for ancient life on Mars is Dr. Bethany Ehlmann. Hey, Bethany.
Hi, Stephanie. How are you doing?
I'm doing great. I've got butterflies. I've got energy. But I'm so excited to be sharing this time with you guys. We've been socially distant for 11 months
That's
now.
Right.
We're maintaining distance because it should come as no surprise that safety is really, really important to NASA, both for our flight hardware, but more importantly for our people. And that's why you're going to see us keep our distance. We're going to keep these masks on at all times, but it doesn't mean we're not going to have any fun. So keep those questions coming. To give you some time to think about them and know what kinds of things you can ask, I'll be talking to each of our experts a little bit up top. So Bethany, you're on the science team. What is your official title, and then what does it mean in plain English?
Okay, well, my day job is I'm a professor of planetary science at Caltech, but for the Mars 2020 mission, I am privileged to be a co-investigator on the science team, and I'm a part of two instruments, Mastcam-Z and SHERLOC. So what does that mean? That means that day to day, I get to participate in looking at the data as it comes down, figuring out what is going on Mars, and then working with the engineering team to plan the next steps of the rover over the coming days, weeks, months that we'll be exploring on Mars.
All right, so we've got this fabulous model.
We do.
We can't let this go to waste.
Nope.
Can you give us just a little guided tour of the science payload on this rover?
Yeah, sure. So, well, what we've got up here are what we call the remote sensing instruments. That means we look at things from afar and take pictures or analyze them. So the two instruments, so the instrument that I work on that's on this mast are the Mastcam Z Cameras. So these are twin stereo color infrared cameras that take the best science images of the surface for our exploration. And you know what's really special about these is not only do they have like crazy powerful zoom lenses to get a microscopic view from far away, but we're also getting that view in the infrared. And so that means we can tell the color, from the infrared colors, we can tell what the rocks and the soils on the surface are made of. So that's super exciting. These cameras here you might see, you might ask, what are those? Well, those are our navigational cameras that take color pictures to help the rover drive. The giant Cyclops eye that you see here is SuperCam. It has a microscopic imager. It has a couple of spectrometers. One of the spectrometers even fires laser beams at rocks and soils. Yes, it has a laser in its head, and it is geared toward understanding the chemistry and the mineralogy of the surface. Moving on, that's not all, because once we use our remote sensing suite to zero in on where we're going, then once we get to the destination, drive to the destination, then we can pull out this beefy arm here and get up and close and personal to the rocks to investigate them. So what you're seeing right here is the core assembly. Now Mars 2020 is really special because it will host a drill bit here. It's not really shown on the model, but actually it's shown retracted inside the model. But it has a bit that allows a core about the size of a piece of chalk to be pulled into a sample tube, and then that sample tube is then put under the belly of the rover, tucked in for safekeeping and eventual return to Earth. But how do we pick the best samples, right? That's the key question. That's where these other two bits on the arm that you see here. This is the pixel instrument that measures chemistry, and the instrument over here is the other one I work on called SHERLOC, and SHERLOC takes microscopic images of the surface, but in addition to a picture, it uses UV fluorescence spectroscopy, so ultraviolet radiation, to get a sense of what the minerals and the organics are also within that microscopic image. So you can actually trace, you know, things like potential fossils, right? If you see a line of organics and sediments. So this is the business end that lets us really select what we want to do with this core.
Okay, so we're getting some questions in, and I want to make sure that we work them into the show. First up from Nathan Baker, what will our approach be if we find very ancient fossils?
If we find ancient fossils, it will be an amazing day on Mars because we will have hit the scientific jackpot. I mean, that's one of the reasons that we explore, right? We're all interested, many of us are driven and interested by the question, like, are we alone, right? Is there other life elsewhere in the universe? One way to do that is by looking at the sediments of Mars. So the rocks in the sediments of Mars. So what we'll do is, first of all, we won't just yell fossil because we're scientists. We take a cautious approach, right? So we're gonna look very carefully and measure if we see something that looks like a fossil, like to our eyeballs. Then the next thing we check, is there anything about it that's unusual in the chemistry or in the minerals, right? So that would point to maybe it is special, maybe it got fossilized. We would also look to see, is there organic matter in there? Carbon, the stuff of which we are built. Can we see any of that associated with the fossil? Because really, you know, extraordinary claims require extraordinary evidence, so said Carl Sagan. And if we're going to make some sort of a life claim, we need a few lines of evidence. So what we would probably do is pick the best spot on the rock with the most lines of evidence that suggested fossil life. Then what we'd do is we'd take a sample of it with this core and bring that tube back to Earth for study in the best labs here.
So this rover looks an awful lot like Curiosity.
It does.
But it is very different in a lot of the ways that you have mentioned, like that coring drill, that it is going to cache those samples for a future mission to return. What are some of the other key differences between this and other Mars rovers over the years? That's Sid Haint's question.
Yeah, good question. I just have time to name a few. But one of the differences from the previous iteration of the rover, the Curiosity rover that's now at Gale Crater, is the wheels. So these guys, we learned that pointy rocks on Mars destroy wheels. And so wising up to this advice, we have beefed up the wheels on this rover to give them an extended lifetime, even if we encounter, you know, really sharp, pointy rocks. There's no AAA on Mars. If you bust your tire, there's no tow truck, right? So we got to make sure that our wheels endure the entire mission. Another key difference you're going to hear about shortly, and that's we have an in situ resource utilization experiment called Moxie that you'll hear about that takes carbon dioxide and turns it into oxygen, but more on that in the next segment.
All right. Well, I know that you are a very, very busy person who's got big plans ahead. If we have a good day on Thursday, you'll just be clearing your schedule for what? The next
Science on Mars.
The next 2 Earth years, one Martian year at least. Bethany, thank you so much.
Pleasure.
For your time today. And with that, we'll let you go and keep those questions coming, folks. We want to hear from you. Up next, technology on this rover to help future life on Mars in the form of astronauts. So, one of the key pieces of engineering on this rover is called Moxie. And here to tell us more about it, Dr. Asad Aboobaker. Hey, Asad.
Hi there. Hey, Stephanie.
All right. So I will start with the same question that I asked Bethany. Can you tell us what your formal title is with the project, and what does it mean in plain English?
You know, that's a hard question, actually, because my title has changed so many times as a part of Moxie. Right now, I just call myself a systems engineer.
All right. All right. You're like the producers of engineering.
Something like that.
Okay. All right. But Moxie, you can tell us about Moxie.
Yep.
What does it stand for? What does it do? And why do we care?
Moxie stands for the Mars Oxygen ISRU experiment. So ISRU is that acronym that Bethany mentioned. That's in situ resource utilization, which is going somewhere and using the materials you have available there and doing something useful with them instead of carrying everything with you.
Excellent. Okay. And so Moxie in particular is going to be extracting oxygen from that thin Martian atmosphere. I think I would be remiss. You guys can probably hear us with our lavalier microphones. It is extremely windy here today, and the wind, the good news is that the wind on Earth imparts a lot more force than the wind does
That's right.
on Mars.
Right.
But since we have the model, do you want to point out where Moxie is?
So you can't see Moxie because Moxie is buried inside the rover. It's basically kind of inside the belly, mounted somewhere in here, but buried in there. The only thing that's on the outside that's part of Moxie is a little box here that has a filter where we draw in the Martian atmosphere, and it goes in through the filter and then through a tube that connects to the box that's inside that has all the guts of Moxie.
So how long after landing will you get to start turning Moxie on and see if it works?
We'll be doing a few checks probably within the first few weeks, and then the first time we produce oxygen probably around a month in. We are only one of many instruments and payloads on the mission. Obviously the helicopter has to do its thing. There's a bunch of science instruments that need to be checked out. So, we're good citizens and we're going to wait our turn.
Oh, it's all teamwork makes the dream
Absolutely.
work, man. So I'm going to butcher this, astromamium, I am sorry, but we're going to get your question in. What are the next steps after it is working?
Well, Moxie itself is going to be run numerous times over the course of the mission for Mars 2020 Perseverance. So the idea is that we want to use Moxie to understand how the technologies behave over various environmental conditions on Mars. So we've got winter and summer, night and day, and then dust storm season, which is something that any Mars mission in the future that's going to be operating for a long period of time will have to deal with dust because it's prevalent. It's always there, and you have to be able to deal with it. So these are the kinds of things we want to learn over the 2 years that we're going to be spending operating Moxie.
So Susan wants to know, what are you going to do with the oxygen that you produce?
Nothing. Well, that's not entirely true.
Nothing. That sounds so wasteful.
Yeah, no, well, we don't produce enough oxygen to do anything really useful. So this is a technology demonstration. So we produce a little bit of oxygen. We run it through a set of sensors that measure the gas that we produce, how pure is it, how much are we making, and then we just dump it out the side because we don't have a way to store it or do anything else that's useful.
Okay, so you measure how much you got and just let it go. It's just like Elsa on Mars.
Exactly.
Okay, John Henderson asks, since Mars dust is so fine, how do you clean Moxie's filter?
We don't, actually. We have sized it. We've done wind tunnel testing at low pressures to see how, with simulated Mars dust, to see how quickly the filter will clog. And it's been sized so that over the course of the mission, the amount of accumulation in the filter is actually pretty low.
Fantastic. So what's next for you if Moxie is successful?
Well, for me, I'm working on other missions that are not Mars related, but for Moxie-like technology, it's basically trying to understand how to scale it up and prepare for actual human exploration.
So we talk a lot about having oxygen for astronauts to be able to breathe, kind of like what we saw in The Martian.
Right.
But oxygen is useful for other things too. So you'd be making rocket fuel?
That's really the main goal, actually, is to produce enough oxygen that you can then fuel a rocket and use it as the oxidizer for a rocket that would be used to get humans off the surface of Mars and get them back on their journey back home to Earth.
That is super cool and super key. We always send the robots first, right?
That's right.
Figure out all the tough stuff before we put human lives on the line. And we have put your human life on the line long enough. We're going to let you get back to your preparations for landing. Where will you be on landing day?
I will be comfortably at home with my cat on my lap and with a video call with all of my colleagues.
This sounds very relatable. I think
yes.
Much
I'm
of
sure
the world.
Everyone out there, everyone in the internet can relate.
Okay. Thanks so much, Asad.
Thank you.
Okay. But we're not done. We're not done. We're staying behind the scenes here at JPL, and we're going to go up to mission control and learn a little bit more about the engineering of this mission. And how do you land on Mars? What do you do with it? How do you run that rover once it's on the surface? So I'm going to go ahead and let you move ahead. We're going to meet up with one of my friends and colleagues, Diana Trujillo. Hey, Diana.
Hey, how are you doing?
Good. You look awfully relaxed for being this close to landing.
Well, you know, we work so hard that at some point you just need to just enjoy the ride. It's going to happen regardless. So, and we're comfortable with what we have done. So we got it. We got this We are ready.
Okay, all right, let's let you go ahead, Gabby. We're headed up the steps of building 180. This is our main administration building here at JPL. It's all of our top brass. Usually lives in non-COVID times, but we've been working remote for 11 months now. It doesn't, but it's still March of 2020, right? How could it possibly be February of 2021? If you folks out there watching on the internet, in the after times, know that you can come and take a public tour of JPL, and you'd walk up through these through these doors where everybody is always having a good time. We're always doing exciting things, and other people are going live too.
Hi.
That's Lyle from our education group, who may be live with a team right now. So anyway, another Perseverance rover. Let's go ahead and go up to mission control.
Well, yes, Stephanie, I was hearing that Bethany was talking about all the fun things that we're going to do with the sample.
Yes. I mean, the science team can't wait to get their paws on this, and they want to take this rover to the most dangerous places they can. What's the push-pull like between the engineering team and the science team?
That's a great question, because we have to figure out a way of working together. At the end of the day, the science team is the one that knows how we should be or where we should be going. And then we are the ones that can enable that by helping get there on the fastest way or in a way that is safe. So yeah, it's a happy family in a way where you disagree and you have to find a way also to agree.
Well, right now we are walking up the ramp to the Space Flight Operations Facility, aka SFOF, aka the dark room, aka mission control. And this is the room where it happens, folks. This is the center of the universe, and it's got some new flare. There's our old flare, and then up on the ceiling here we just installed the worm. I know there are a lot of graphic design fans out there who absolutely love the NASA worm, so we put it in. It's subtle, it's very nice. Most JPLers haven't seen this yet because it was installed after we started working off lab. But let's go inside. So here we are in the newly designed lobby of Space Flight Operations Facility. But let's go inside, it gets even better. As you come up these stairs into the viewing gallery, this is a space where in normal times we would have lots of VIPs for a major mission event. Back when Mars exploration rovers landed, then California Governor Arnold Schwarzenegger was up here. We've
Nice.
had all kinds of folks. So I realized, Diana, I was so breathless and excited to see you that I didn't ask you about the work that you have been doing to this point. You want to tell everybody what it is that you do, what you've done, and then what you will be doing?
Sure, absolutely. So in the past, I will say past meaning up to maybe April of this year, I was working with the team that actually does all the testing of the hardware and the software of the robotic arm and the two instruments that Bethany went over that will be doing the scan on the surface. So I had the pleasure to actually be on the clean room, testing all of that thing, ship it to the Cape, and then see it get on the rocket. But now my current job is I'm one of the 4 flight directors for surface operations. So I will be there actually on day 2, on sol number 2, when we actually have already landed and see it all unfold.
Excellent. Well, all right. We've got some beautiful visuals here. I think people are probably very curious. Can you give us a little tour of what we're looking at?
Absolutely. So I love this room because the fact that it looks super cool, it's actually a very cool room. So a few things that you can see here. So right under us, you'll see Curiosity Ace. That's the station where all the commands that go to the Curiosity mission go. So the person sits there, sends them from here. On the front row, you will see the data controllers and the comm chief and the deep space network right on the middle. This is where all the information from multiple missions that NASA JPL is actually flying gets to this room. All that information then gets routed to the right teams on their mission control. And one of the things that is super cool also about this room is that it's an international room. I see it like that because you can see from the displays on the front, you got the antennas that are on Madrid, the antennas that are on Goldstone, which is the US, and then the antennas that are on Canberra in Australia. Those are the 3 big sites around the world where you can see any spacecraft that is on a planetary mission. So all of those are the ones that track those missions.
Right, because we need those 3 stations. You have to have line of sight to be able to talk to things out in space. You got to have an unobstructed view of them to get those radio signals, either commands up or data back. So as the globe turns, as one station sets, the next one comes into view.
That's right.
So you folks out there on the internet, if you are interested in seeing what dishes are speaking to which spacecraft now, you can go to your favorite search engine and type in DSN now, and you will get a visualization tool that is powered by the, well, we're looking at it live. What we have is what you have. So you can do this from your phone and tell everybody, you know, these are the signals that are coming in from space right now. So you'll be connected with us. We'll be alone together here on the internet.
And I love what you said, because even from the screen you can see the DSS-25 from Goldstone is actually tracking M20, meaning us, Perseverance.
Ah, very nice, very nice. Right now the one-way light time between Earth and Mars is about 11 minutes. It'll be 11 minutes 22 seconds if I remember my press kit on landing day. So we'll be broadcasting live from this room, and we'll get to a little bit more about that at the end of our show, how you can tune in live and be part of that action. But before we get to that, Deanna, the dark room here is not the only thing in this room we should call out.
Exactly. So, okay, so this is really cool, but then to the left, you will see the room where entry, descent, and landing will be happening. So all the team members from operations that will be sitting on station is on the left side, where you can see the bottom of the American flag. You can even see the flight director and the EDL, entry, descent, and landing, activity lead signs. So whenever you see the broadcast, you're going to be watching that room live.
Okay, so let's go ahead and go to some questions from the internet here for Deanna.
Sure.
Danielle asks, what's the difference between entry, descent, and landing on Perseverance compared to Curiosity?
Oh, I like that question. Okay, so one of the differences that is very important is the way that Curiosity came in. You know, we did the whole navigation, it finds where we have to actually land, but the difference with Perseverance is that this go around we're going to do it with eyes open. That's how we describe it, which is it's actually taking images as it's coming in and then comparing it with an onboard map to determine exactly how to navigate to safely get to the place that we're going to land. So yeah, that's a key difference.
All right, so Emma Harding, tuning in from the UK, is there with her 9-year-old son Oliver, who is super excited for the mission. He wants to know, how long did it take to build the Perseverance rover, and how many people did it take to build it?
Oh, that's a great question. So it takes a lot of time. It takes approximately from the beginning of conception of like saying what's the design looking like to the point where we actually put it on the rocket. It's approximately 10 years or something along those lines. And it's a ton of people. It's a ton of people. In even not so many people, it's also people from different countries, from different languages. It's very great because you come in together as an international group and an international team to build this thing.
And once we're on the surface, Daniel Ryan on Facebook asks, how long is the mission?
How long is the mission? So the mission itself has 2 different stages. The actual primary mission, it will be a 2 Earth year, 1 Mars year on the surface of Mars. And so we hope that we can answer the question and the objectives by that time. But usually the missions then eventually get extended because we're still on the surface of Mars. And in this specific case, we have nuclear power, so we can stay longer. But the primary mission is 1 Mars year.
All right, so we're going to get all that seasonal data that the scientists are so hungry for. And Moxie too. Moxie needs to see how it behaves over all the seasons. Okay, Christopher Mick on Facebook asks, how much of an orbit does Perseverance make of Mars before starting entry, descent, and landing?
Oh, how much of an orbit? That's a good question. So we're coming in straight into Mars. We do TCMs to correct exactly where we're going to do the entry point. But once we hit the entry point, we're just going straight in through the atmosphere to land. So there's not much time that we're wasting. As soon as we feel the atmosphere, we're just going in.
And on the software side of things, Noor the Door asks, how complicated is the automated landing sequence and who wrote the code?
Ooh, that's a really interesting question. Okay, so very complicated. I think the way that I describe it is we're touching the top of the atmosphere of Mars at 20,000 kilometers per hour, which is insanely fast. And then the complicated aspect of it is that it has multi-parts that come off at the specific instances while taking pictures and having retro rockets and landing. So you can imagine that just my description is super complicated. So now, I will say we tested constantly, we tested multiple times, and the code itself is actually a team. So it's a team of people that write different pieces of that area, the devices that are going to be used, how those devices are going to get integrated, and then the software itself, it gets built by lots of different people that we get to test with lots of different more people.
Okay, you touched on this a little bit with the needing to see the surface to choose that landing site. So Nancy Wilkins wants to know, is it the rover Perseverance or the descent module taking those images to find the safest landing site?
The safest landing site. That's a really good question. So when the back shield of the rover comes, so it has a heat shield and it has a back shield. When the heat shield comes out, there is a radar that we point down to find actually that location of where we're going. So it is not per se the actual rover itself, it is actually the descent stage that has that radar, the LiDAR that will find the location. But there's one thing that I like about your question, which is the rover itself on a side also has a camera that will be taking pictures as it's coming down. So we got two imagers giving us information.
All right, Avina's HJ98. Can I be a member of this mission? How can I work for NASA?
Oh my goodness, of course you can be a member of this mission. It takes everybody to get to do this, right? Like the questions are things that we have never asked ourselves before, things that we have never tried before. So we kind of need everybody to come up with their own way of seeing things from their different angles. So I will say go to nasa.gov, check out JPL for any openings that there is. And if you are not interested in those jobs, you can certainly follow the show and be part of all of this, even with the online activities that Stephanie and her team have.
All right, that is a perfect segue. If you want to know how to participate in the mission, if you want to join our Mission to Mars Student Challenge, if you want to join the conversation with the rover on Twitter and Facebook, all of that you can find at go.nasa.gov/Mars 2020 Toolkit. And oh my goodness, here it is. It's Tuesday afternoon, Thursday. We're going to be live streaming from this room. We'll be live streaming in 2D. In 360 degrees, and for the first time ever, en español.
En español, yes, for the first time ever, vamos a tener un show en español del aterrizaje de Perseverance. Empieza a las 11:30 Pacífico, 2:30 Este. Así que si nos quieres ver en YouTube es NASA-ES. Nos vemos ahí.
So this is NASA. We got space for everyone. We hope that you will join us. We'll see you online. #Countdown to Mars.